This video covers everything you need to know about the three main types of system of equations questions that show up on the SAT and ACT. It also has practice questions so that you could check your understanding. If you want to skip ahead, you can check the description box below for timestamps. You could also listen to the lecture part on double speed. Here are 3 examples of the types of questions you'll be able to answer at the end of this video. Here's a reminder of what y equals mx plus b means. M is your slope, which is your change in y over your change in x. Here's a reminder of how to get the slope if you're given a graph. So if you weren't given that equation of a line, you could just look at the graph. You could pick any 2 points and you could draw a slope triangle like this. And then you're just going to count your vertical distance is 3 over your horizontal distance is 1. That's 3 over 1. So that's how you get slope. Let's say that they gave you 2 points on the line. So we could just pick 2 points. So we could start with that point that we just used there, 0, 1. And then our other point right here was 1, 4. And then the other way you can calculate slope is you can do change in y over change in x. So that just looks like this, 4 minus 1 over 1 minus 0 gives us 3 over 1 as our slope. And then if we were filling in an equation of a line, that is your m term, so that just goes there. That would be 3 for your slope. Where does the 1 come from? It's just your y-intercept. You can get that visually from just looking at the line and where it intersects the y-axis. So that is 0, 1. The other way you could get it is, let's say that you didn't have a picture. If you had that the slope is 3 and you had a point on the line, you could plug that point in for your x and your y value, and that would let you solve for your b value. Here we have a summary of all the different situations that could happen. So you could have different slopes. If there's different slopes, it means there's one solution like you have here. You could also have perpendicular lines, which would be one solution still. Those lines have slopes that are negative reciprocals of each other. If they have the same slope, different y-intercepts, those are parallel lines, which means there's no solution. The lines never intersect at any point, meaning no solution. And another situation that you could have is if you have the same slope and the same y-intercept, then those are the exact same line. That means there are infinitely many solutions because they are the exact same line. Every single point on the line is a solution to both equations of a line. Notice this example here where the second equation is just the first equation with each term multiplied by 3. That would be infinitely many solutions. When you graph it, you see that they are the exact same line. In contrast, if you have different slopes, even if it's the same y-intercept, those are going to intersect at exactly one point. That's going to be one solution. So keep in mind, same slope, it's parallel lines if the y-intercepts are different. If you have the same slope, same y-intercept, it's very logical. They're the exact same line. If you have different slopes, that means they're going to intersect at exactly one point. It does not matter if the y-intercepts are the same. So notice the y-intercepts are both 1. It really doesn't matter. It's the slopes that are making it so that you have exactly one solution because those lines are going to cross each other at one point. That's just the nature of how lines work. You could solve this question in a number of ways. I solve it with plugging in another video about strategies for systems of equations. In this video, I'm going to explain how to do this with elimination. So I'm going to multiply the second equation by -2 because I want to get the 4y in the first equation to cancel. Then I'm going to rewrite the first equation here. I'm going to distribute the -2 to the second equation, and I am going to line my terms up as I'm doing that. So I'm going to get -4y, -2 times -x is positive 2x, and then -2 times -19 is positive 38. Then you're just adding these. Your y terms cancel. You have 5x equals positive 15. That means that x is 3. If you look at your answer choices, you only have one answer with 3. So you could circle that if you're feeling confident, if you feel like you didn't have any minor missteps. The other thing you could do to feel confident is you could plug in x equals 3 into either equation and see if you get a true statement with your corresponding y output of -8. So it would be 3 times 3 plus 4 times your y, for that one is -8, equals -23. That is true, so that should help you feel confident that you did it correctly. If you wanted to be extra careful, you could plug it into the second equation and make sure that it works for that also. This question asks us, in the equation above, a and b are constants. If the equation has infinitely many solutions for x, what is the value of b? When we're talking about infinitely many solutions, we mean that they're the exact same line, they have the same slope, the same y-intercept. So you're just going to distribute your a term, and then you're going to set the slopes for the lines equal to each other. You're going to set the y-intercepts equal to each other, and you're going to be able to solve for b. So this is what we have so far. And then this allows us to calculate the value of a, because we have ax equals 4x. That means that a is 4. Then we can substitute that in as a here. So we have 4b equals 10. Then we divide by 4 on each side, and that gives us our value for b. b is 10/4. This could also be written as 5/2 or 2.5. This last question is about parallel lines. Let me show you how I know that. It says, in the system of equations above, k is a constant and x and y are variables. For what value of k will the system of equations have no solution? If it's a linear system, meaning that your x is raised to the first power for both equations, and it says there's no solutions, it has to be parallel lines. So what we're going to do is we're going to determine the slopes of the lines and set them equal to each other. I am going to show the work of rewriting these equations in slope-intercept form because that's the easiest way to find the slope while ensuring that you don't make any mistakes, because notice that the answer choices, you have answers that are positive and negative, which is a clue that you have to be extra careful about your positive and negative signs for this question. So I'm going to rewrite this first one. I'm first just moving that kx across the equal sign. I'm not even worrying about the y-intercepts because remember, the y-intercepts don't matter as long as they're not identical to each other, which isn't even an option here. All right, so then I'm going to divide by -3. Divide by -3. So that first slope is positive k over positive 3. And then let's rewrite this one here. So first I am just keeping the -5y, and then I am moving that 4x across the equal sign, so I get -4x. I'm not even worrying about the y-intercept because it does not matter. It could matter in another question, but in this question you can tell that it doesn't matter. So then your slope is going to be 4/5. That's positive because you have negative divided by negative. Then we're going to set these slopes equal to each other because that's what happens in parallel lines. Fraction equals a fraction means cross multiply. We get 5k equals 12. Last step, divide by 5 on each side, and that gives you that your answer is positive 12/5. As you can see from these example problems, it's important to understand these 3 different situations that can happen when you have 2 lines. First, you could have different slopes, meaning that there's one solution, one point of intersection. Next, you could have same slopes, different y-intercepts, which would mean the lines are parallel and never intersect, no solution. Lastly, you could have the same slope and the same y-intercept, meaning that those are the exact same line, and therefore there are infinitely many solutions.